thanks for being here today. We're going to dig into one of the most fundamental, yet often overlooked, aspects of arboriculture: tree nutrition and fertilization. As arborists, it's easy to focus on pruning cuts, structural defects, and pests, but we have to remember that what's happening below the surface at the root-soil interface is just as important to tree health as anything we can see in the canopy. Let's start at the top. Trees, like all living organisms, need nutrients to function. They require 17 essential elements. Of these, 3, carbon, hydrogen, and oxygen, come from air and water, mainly through photosynthesis and transpiration. The remaining 14 elements must be absorbed from the soil solution through the tree's root systems. These nutrients are split into 2 broad categories: macronutrients and micronutrients. Macronutrients are required in large quantities. They include nitrogen, critical for leafy growth and chlorophyll production; phosphorus, vital for root development and energy transfer; potassium, supports disease resistance, water regulation, and overall vigor; calcium, helps build cell walls and support root and leaf development; magnesium, central to chlorophyll production; and sulfur, plays a role in enzyme function and protein synthesis. Then we have micronutrients, needed in smaller amounts but still essential: iron, manganese, boron, zinc, copper, molybdenum, chlorine, and nickel. Deficiency in any of these can cause very specific symptoms like chlorosis, leaf curling, or poor growth. But here's the catch: nutrient deficiencies don't always mean the nutrients are missing from the soil. They might be there but unavailable to the tree. So what determines nutrients availability? That's where soil chemistry comes into play. Soil is not just a place for roots to anchor, it's a dynamic living environment made up of minerals, organic matter, water, air, and billions of microorganisms. These components interact constantly to release, transform, and transport nutrients. One of the biggest influences on nutrient availability is soil pH, a measure of acidity or alkalinity. Most trees prefer a slightly acidic pH, around 6 to 6.5. If the soil is too acidic or too alkaline, certain nutrients become chemically bound and unavailable to roots, even if there's plenty present. For example, iron becomes unavailable in high pH soils, leading to interveinal chlorosis, especially in species like oaks and maples. Other important soil characteristics include texture. Sandy soils drain quickly and may leach nutrients. Structure. Compacted soils can suffocate roots and limit nutrient access. Organic matter improves nutrient holding capacity and feeds soil microbes. And cation exchange capacity. This is a soil's ability to hold on to positively charged ions like calcium, potassium, and magnesium. That's why soil testing is non-negotiable. You can't diagnose a deficiency by looking at a leaf and guessing. You need a lab analysis to know what's in the soil and what the pH is doing. Now let's talk fertilization. It's tempting to think of fertilizer as a universal cure. Throw some down and the tree will thrive, but it doesn't work that way. Fertilizer should never be applied blindly. It's not a treatment, it's a supplement, used only when a nutrient deficiency is confirmed or when a tree is under stress and soil analysis supports it. In fact, over-fertilization can be just as harmful as under-fertilization. Excess nitrogen can cause excessive weak shoot growth, increased susceptibility to pests and diseases, reduced root growth, and nutrient imbalances. In urban settings especially, we have to be careful. Fertilizers can leach into groundwater or run off into storm drains, affecting water quality and ecosystems. That's why we focus on slow-release fertilizers. They deliver nutrients gradually, more in tune with how a tree would naturally receive them in a forest environment. Application methods vary depending on the tree, the site, and the goal. There's broadcasting, granular fertilizer across the root zone, soil injection to place nutrients deeper into the root zone, fertilizer spikes or tablets, though these can create uneven distribution, and compost or mulch rings for organic slow-release feeding. And don't forget, timing matters. Fertilizers should be applied when roots are actively growing, usually in early spring or late fall. Fertilizing during drought or dormancy can stress the tree or go to waste. To sum it up, healthy nutrition begins with a healthy soil. Fertilization is just one tool in our toolbook, and it should be used thoughtfully, based on science, not habit or marketing. As arborists, it's our job to promote long-term tree health, not just short-term fixes. Understanding tree nutrition and fertilization helps us make smart, site-specific, and sustainable decisions to keep our urban forests strong. All right, now it's time for some call-in questions. Caller 1, Maria from Portland, Oregon. Hi there. I have a young maple in my yard that's showing pale yellow leaves, but the veins are still green. What could be causing that? And what should I do? Great question, Maria. That symptom is called interveinal chlorosis, and it's often linked to iron deficiency. In your region, alkaline soils are common, and when soil pH is too high, iron becomes unavailable, even if it's present in the soil. The first step is to get a soil test to confirm the pH and nutrient levels. If it is an iron issue, you may need to adjust the soil pH or apply an iron chelate, which is a form plants can absorb more easily. Caller 2, Darnell, says, I've heard people say you should fertilize your trees every spring. Is that true, or could it do more harm than good? Great question. The short answer is not always. Routine blanket fertilization isn't recommended. Trees should only be fertilized when there's a documented nutrient deficiency, or when a tree is showing symptoms of stress that could be linked to poor nutrition. Over-fertilization can actually damage roots, cause weak growth, or contribute to runoff pollution. Always test first. Fertilization should be targeted, not habitual. Caller 3, Jess from Denver. What's the best kind of fertilizer to use on urban trees, and how do you apply it? Good question. In urban environments where root zones are compacted or disturbed, trees benefit most from slow-release, nitrogen-based fertilizers. They should contain both macro and micronutrients, and ideally be low in salts to avoid damaging roots. Application can be done via soil injection, broadcasting over the root zone, or using a mulch ring with compost or organic amendments. Whichever method you choose, focus on the area within the drip line and extend a bit beyond. That's where most absorbing roots are found. Alright, now it's quiz time. How many essential elements do trees require for growth and development? 17. Which 3 essential elements do trees obtain from air and water? Carbon, hydrogen, and oxygen. What is interveinal chlorosis typically a sign of? Iron deficiency. What is the most reliable method of determining nutrient deficiencies in soil? Soil testing. Why is slow-release fertilizer generally preferred for trees? It provides nutrients gradually and reduces leaching. At what time of year is fertilization usually most effective? Early spring or fall. What does a high soil pH do to nutrient availability? Decreases availability of some nutrients.